Right, so I challenged you and said, how are you going to find U2? Well, what do you know about state 2? You need two properties to find other properties. I know one property is the quality. I know that's the phase. It's 100% saturated vapor. I also know it's a rigid tank, right? So a rigid tank, if V1 is equal to V2 and M1 is equal to M2 because it's closed, then V1, which is V divided by M, is equal to V2 because these are all constant. That's what I'm saying here. A rigid closed tank has the same total volume and the same specific volume. So that's going to be my other property. I'm going to use X2 and V2 to find U2. And so I can find the work in. Okay, are we done? Well, we could go ahead and find the work in now, but that's not the only thing the problem asked for. The problem also asked for the entropy generated. So you're welcome to go look these properties up now, but I don't want to have to double handle properties. I'm going to see if there's any other properties I need right now. I'm going to look those up too. Now, I already know I need V1, right? I need V1 to find V2, and that V2 is going to give me U2. So I know I need these two properties here at state 1. Do I need anything else? Well, the problem also wants to know about the entropy generated. Okay. How do we find the entropy generated? Well, I mean, I do have this equation up here that's not actually intentional. Yeah, we could use this, although I don't think that's not necessarily the best tool. For me, when I see entropy generated, and I've got a process from state 1 to 2, the first thing that comes to mind is a second law equation that we've already derived for a process from state 1 to state 2. Delta S is right here, right? So let's look at this guy. So this is we've done our first law. I've said here's the properties I need. Now before I go look up properties to find S-gen, let's look at the second law. Again, I've got a process from state 1 to 2, so you can pull this right here. Big S2 minus big S1 is equal to the integral of del big Q over T plus big S-gen. Big S2 minus big S1 is equal to, this is M times little s2 minus little s1. Right? I can't go look up big S's, but I can go find little s's. So I can go look those up in the property tables for water just like I can U's and V's. So I know I'm going to need those. So I need my properties here. What do I know about the heat transfer? It's well insulated. So if I add up a whole bunch of zeros, if all the little Q's, again, this is saying add up all the heat transfers, all the little Q's, all the little heat transfers to go from state 1 to 2. If you add up a whole bunch of zeros, you're still going to get a 0. So delta S is equal to the entropy generated, which is what we're asked for. Okay, I know the mass. I can already say that I can find the properties. So pause it here, pause the video, go look up these properties. Make sure you know how to do this. Make sure you can do this quickly. Write them down if you like, but you need to be able to do this quickly. I think I've got a solution here. Go ahead and pause it, go find these properties, and then come back. All right, you have the properties? Let's see how we did. I think I've got a solution here. Yeah, first law. Work in is mass times delta U. So far, so good. Properties. Did you find these? Remember, it's quality at state 1. How's that on the screen? I know it's a little small. I'll pick it up here. I don't know if this helps. Right? So state 1, you've got a quality there. Let's see if I can rotate that where you don't get the glare. Okay. So specific volume of state 1, entropy at state 1, internal energy at state 1. I think these are probably pretty close to what you should have in the 9th edition. This is probably from an older edition of the book. So you might have slightly different values, but these should be really close. What do we do then with this second one? Well, did you find the second one? That's a little more challenging, right? We know V2 is equal to V1. We know it's saturated vapor. So how the heck do we find this? Well, let's go look. Here's what we know. Right? We know we found V2 to be 0.4243. And that's what we're going to use to find S2. You know, X2 is 1. And both U2 and S2 we're going to need based off of this V1. Alright, let's see if I can get my book up here. We got water in metric units. Okay, so it's saturated, so I need to go to the saturated water table. I'm looking for saturated water vapor with this specific volume. So you're going to hear a pop here. This is not the best visual, I apologize. But so we're looking for 0.4243 as my specific volume for saturated vapor. Here we are. We're between these two rows. 42, remember, 4243 is our value. So I'm between these two rows. So my U value will be between these two, between 2554 and 2559. And my S value, you can see over there on the far right, is going to be between 6.8827 and 6.8371. And then we're just going to interpolate between those. Okay. So set up the interpolation. If you need help, send me an email. Set it up. Send me a picture. Say, hey, Steve, I'm not sure where to go with this, and I'll be happy to help you. Okay. You need to be able to do this. This is, as you can see, getting these values is a small piece in the bigger puzzle. Right? Most of your points, if this were a test problem, most of your points is going to be right here and right here. If you can write these two equations correctly for this particular problem, these are the bulk of your points. This is going to be, out of 20 points, out of 20 points is going to be maybe 4 or 5 at the most, all 5 of these properties. No more than 5 points for all of them. Okay? The bulk of the points is showing me you know how to find a solution. If you show me you know how you're going to find these properties, just drawing this up, say I'm going to use P1 and X1 to find these, and X2 and V2 to find these. If you'll draw that out, I'm going to give you some points for that. Even if you don't have time to get these solutions out, you show me, hey, Steve, I know how to get these, I just don't have time, and this is going to take me some time, so I'm going to move to the next problem and get most points on it. Okay, that's fine. That's not a bad strategy. Make sure your first and second laws are correct. Show me, and then you can say, all right, well, here's the properties I need. Go find the properties, and we go from there. Okay? So hopefully that helps. And now it's just plug and chug. All right? Change in entropy, which is equal, we've already said the change in entropy is equal to the entropy generated because there's no heat transfer. So you've got that here, and you've got the work in from the electronic device given there. Oh, sorry, there's a glare. I love this little lamp for my writing surface, but it's not great for the tablet. I apologize. Okay, questions for me? Send me an email. You can leave comments down below. I'm happy to. Some of you guys have done that. But if you don't mind the world seeing your comments, that's okay. Again, if you've got a question or a comment, probably somebody else watching this video does too, so feel free to share just like you would in class. Or if you just want to send me an email privately, we can do that too. Either way is fine. Okay? Questions here, guys, let me know. That's a simple example. All right? Let's look here. All right, what do we got? Okay, that's the end of that one. So let's look at, you know what, we'll just quit that one here, and we'll start lecture 18 on the next video. We've got a solid 10 minutes here. So yeah, so we'll just start lecture 18 on the next video. Be back with you guys in a little bit.